welcome to another video. Today we are doing Chapter 9, Lesson 7, Independent versus Dependent Events. Our learning goal is that students will be able to identify and find the probability of independent and dependent events. Make sure to write down absolutely everything in this video that is typed or written, and pause the video at any time that you need to slow things down. Independent is when the first event does not affect the second event. A dependent event is when the first event does affect the second event. Okay, and we'll show you some options of both of those. In the first three, we are going to be showing the independent events, and the next three will be the dependent events. Okay, so here is an example of an independent event. Two spinners are spun at the right and find the probability of each. So this is an independent event from this one because when we spin this spinner, it's not going to change this spinner to the right. Okay, so they are two separate spinners and one doesn't rely on the other. So we want to find the probability of it being a 4 and C. So we've got how many 4s on this? We've got 1 4. What am I doing? We've got 1 4 out of how many total? We've got 1, 2, 3, 4, 5, 6, 7, 8. 1 out of 8 total is 4. And how many C's do we have? We have 1 C out of 1, 2, 3, 4, 5, 6 total. So 1 out of 6. So here's the probability of each, and these are independent events. And then what you want to do is you want to multiply these two together. So 1 times 1 is 1, and 8 times 6 gives us 48. So there is a 1 in 48 chances that you will land on a 4 and a C when you spin both of these spinners. You do want to reduce your fractions if possible as well. 1 over 48 cannot be reduced. It cannot be reduced. But if there is a fraction that can be reduced, you want to reduce it. So again, as another independent event, this spinner is different from this spinner. And so when you spin this one, it's not going to affect this one. We want the probability of landing on a 1 and an A. So there is 1 1 out of 1, 2, 3, 4, 5, 6, 7, 8 total. And there are 1, 2, 3 A's out of 6 total. 1, 2, 3, 5, 6. So 1 over 8 and 3 out of 6. Now we need to multiply these together. We cannot cross cancel here. You could reduce 3 over 6 before you multiplied them together, or you can reduce after. 1 times 3 is 3, and 8 times 6 gives us 48. And 48 and 3 can be reduced because both of them are divisible by 3. So you would divide 48 and 3 by 3. 3 divided by 3 is 1. And 48 divided by 3, you can do on your calculator off to the side. So 3 goes into 48 16 times. So 1 out of 16 is the chance of you landing on a 1 and an A when you spin both of these spinners. Okay, here is another independent event, an odd and an A. So we want odd numbers, the probability of landing on an odd number. So first we need to know what our odd numbers are. Our even numbers are 2, 4, 6, 8, 10, 12. You count by twos, right? Our odd numbers are the other ones, right? 1, 3, 5, 7, 9, 11, and so on. You're counting by twos still, but you're starting with the number 1. So we need to circle all of our odd numbers. 1 is an odd number, 7, 5, and 3. So we've got 4 odd numbers out of 8 total. And it wants the probability of landing on an A as well. So we have 3 A's out of 6 total. And then you multiply these together. Now we can cross cancel here. We can divide both 4 and 6 by 2. 4 divided by 2 is 2, and 6 divided by 2 is 3. 2 times 3 gives us 6, and 8 times 3 gives us 24. You can still reduce 6 over 24 by dividing them both by 6. 6 divided by 6 is 1, and 24 divided by 6 is 4. So there is a 1 in 4 chance, 1/4 or 25%, of landing on an odd number and an A. Okay? If you didn't reduce this from the beginning, you would have 12 over 48, and then you could reduce from there as well. Okay, now we come to dependent events. Okay? This one is not difficult, but at the beginning it may seem that way. Okay? There are 10 yellow cards. I've gotten all of our cards off to the left here. So 10 yellow cards, 6 green cards, 9 orange cards, and 5 red cards in a stack of cards turned face down. Once a card is selected, it is not replaced. That's important. It's not replaced. Find the probability of each. So we want 2 probabilities, 2 yellow cards. So we have 10 yellow cards. Out of how many total? We would need to count all of these up, add them all up. And when we do, we get 30. There's 30 cards total. And 10 of those are yellow. So our first option of drawing our first card, of it being yellow, is 10 out of 30. Okay, now, we have drawn one card, and we have taken that card out of the deck. We did not replace it. It did not go back in our deck. So, now instead of 30 total, we took one card away. Now we only have 29 left. We took that card out, took it away. Now, let's say that we drew a yellow card, right? So we took away one of the yellow cards, and now we are left with 9 yellow cards. We wanted the probability of getting 2 yellow cards. So the probability of getting the first yellow card is 10 out of 30. That one is taken away. So now there are only 9 yellow cards left out of 29 total cards. Okay? And now you can multiply straight across. 9 times 10 is 90. And 30 times 29 is 870. Now, these are a lot harder to reduce. And I'm not going to make you guys reduce them all the way. I would like you to try and attempt to reduce them. But they did say on FSA that you guys would not have to simplify answers. So I'm assuming that this would be sufficient. But what I would say is that if you can see a blatant, like very obvious way to reduce, then go ahead and do it. For example, both of these end in zeros, which means we can divide both of these by 10 very easily. Okay? 90 divided by 10 is 9. We just take off the 0. And 870 divided by 10 is 87. So there is 9 out of 87 chances, okay, of pulling 2 yellow cards out of the deck. Okay, so this says the exact same thing. We're dealing with the same deck of cards. Once a card is selected, it is not replaced. Again, we're taking that first card out and putting it away. So it says a yellow card and then a green card. Well, there are 10 yellow cards out of, again, 30 total. But remember, we took that card out and now it's gone away, right? We took that card away. So now we only have 29 cards left. And the next card being a green card. Well, there are still 6 green cards left. Okay, so now we can multiply straight across. You can cross cancel if you would like. Right here, 6 and 30 are both divisible by 6. 30 divided by 6 is 5, and 6 divided by 6 is 1. 10 times 1 is 10. And 29 times 5 you can do on your calculator. And that is 145. Okay, so we've got 10 out of 145. Now, both of those are divisible by 5, but again, if you wanted to leave it as 10 out of 45, I'm okay with that. Your regular teacher might not be okay with that, so you need to make sure that you are reducing all of the way in your regular math classes if that's what they're asking you to do, okay? Let's say we were reducing these both by 5. Okay, 10 divided by 5 gives us 2, and 145 divided by 5 gives us 29. Okay, we've got one more left. Again, these are dependent events, and the reason they're dependent is because when you take out the first card, that's going to affect how many cards are in the second deck of cards. So how many you can pull for the second deck of cards. That's why these are dependent upon each other, because once you do something with the first card, that affects your second probability. Okay, so again, same scenario. It is not replaced. Find the probability of each. 2 cards that are neither red nor green. So neither red nor green. We need to count all of the ones that are neither red nor green. Okay, so here's the red and green, obviously. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 yellows. That is 19 total that are neither red nor green out of 30. 19 out of 30 total. Okay, but now again, we've taken one card out and we didn't replace it. So instead of 19, now we only have 18 cards that are neither red nor green because we took one of these away. So now we are left with 8 and 10 cards left that are neither red nor green. And we took that one card out, so we did not replace it. So our deck is now at 29 cards. Okay, so then you can multiply straight across. You could cross cancel here. 6 goes into both 18 and 30. 18 divided by 6 is 3, and 30 divided by 6 is 5. 19 times 3 gives us 57. And 5 times 29 is 145. Okay, that's all I have for you guys today. I hope you guys have a fantastic day, and I will see you tomorrow.